Today we're going to discuss the binomial distribution formula. Binomial probabilities allows us to calculate the probability of the number of successes out of the number of trials. The simplest way to look at this is with an example. When taking a timed exam, you notice you only have 5 remaining seconds to answer 3 multiple choice questions, each with 4 suggested answers. Since only one answer can be correct for each question, what is the probability that you randomly select 2 correct answers? We call this a binomial experiment because there are only 2 possibilities for outcomes. Either we choose correctly, which means we have a success, or we choose incorrectly, which means we have a failure. The formula for calculating the probability of success is P of R, where R is the number of successes, is equal to N factorial divided by R factorial times N minus R factorial times P to the R Q to the N minus R, where R is the random variable representing the number of successes and N is the number of trials. Now, what you might notice here is that this portion of the formula here is actually just the formula for the combinations. And so, since we will be using our TI-84s, 83s, Inspire calculators to calculate this, what I'm going to do is I'm going to replace that with the notation for combinations. So what I'm going to write here is N combination R times P to the R times Q to the N minus R. So for this problem, we're asked, what is the probability that we randomly select 2 correct answers? So we're looking for P of 2. And so what we have is the number of trials are 3. We have 3 multiple choice questions. And each question has 4 suggested answers. So the probability of getting the answer right is 1/4. We have 1 out of 4 chances to get the answer correct, which means that the probability of failing is 3 out of 4. So as we begin to write this equation, we're looking for 3 combination 2 times the probability, which is 0.25, times R, the number of successes, which is 2, times the probability of failing, which is 0.75, raised to the number of trials minus number of successes, or 3 minus 2, which is 1, which when we type all of this into our calculator gives us 0.14, or 14%. For our second example, it says a study shows that 59% of internet users are somewhat concerned about the confidentiality of their email. What is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email? So as we look at this, the first thing we want to do is to identify the information in our problem. And so the number of trials that we have is obviously going to be 10 internet users, so N equals 10. And the probability for a successful outcome is that 59%, which we'll call 0.59. If we have a 59% probability of success, then our probability of failure has to be 0.41 or 41%. And the number of successes that we hope to get are 6. So now we'll plug this in our formula. So the probability that 6 of the people we randomly sample are concerned about the privacy of their email is equal to, and then I'm going to do 10C6 times 0.59 to the 6th power times 0.41 to the 10 minus 6 or 4th power. And I'm going to type all of this into my handy dandy calculator. And the answer is 0.25. So there is a 25% possibility that exactly 6 of the 10 internet users are concerned about the privacy of their email. This next example is about a one-time fling. Have you ever purchased an article of clothing, worn it once to a party or event, and then returned it to the store? This is called a one-time fling. A study shows that 10% of all adults deliberately do a one-time fling and feel no guilt about it. In a group of 7 adult friends, what is the probability that 2 of them have done a one-time fling? For this particular problem, our number of trials is 7. We have 7 adult friends. And the probability is 10%. So the probability that an adult has committed a one-time fling is 10%, which means that the probability that they have not is 90%. And here we're looking for the number of successes, which would be 2. So again, we call that R. So R equals 2. So the probability that 2 of our 7 friends has committed a one-time fling is going to be equal to 7C2 times 0.10 raised to the 2nd power times 0.90 raised to the 7 minus 2 or 5th power. And then we'll plug this into our calculator and we get 0.12 or 12%. Okay, thank you.